Okay, now let's look at definite integrals that using substitution method. Okay, for example, we want to integrate 1 0 x 2x plus 1 power of 3 dx. Okay, so now for substitution method is we let u equal to 2x plus 1, so du is equal to 2 dx. So dx is equal to du over 2. Okay, so from here we take this section is 2x is equal to u minus 1, so then x equal to u minus 1 over 2. Okay, so now we substitute the u, dx and x into the equation of the integration. So it becomes 1 0, then our x is u minus 1 over 2, and 2x plus 1 power of 3 is u power of 3. So our dx is this du over 2. So we reorganize, so we have 2 and 2 at the denominator, so means we have 1 over 4 integration 1 0 u minus 1 u power of 3 du. So then we have 1 over 4 integration 1 0 u power of 4 minus u power of 3 du. So our integration is u power of 5 over 5 minus u power of 4 over 4 plus c. Okay, so now we resubstitute u into the but first, sorry, in this integration by substitution, when you do integration by substitution, when you substitute the component of x into u, I recommend you not to write down 1 0 at this integration symbols, because when you substitute x with u, so the value 1 changes, it no longer becomes 1 and 0. I will show you later. Okay, u power of 5. Okay, so just integrate the equation like usual. So our final answer is u power of 5 over 5 minus u power of 4 over u. So now we resubstitute value of u into the equation. So it is 2x plus 1 power of 5 over 5 minus 2x plus 1 power of 4 over 4. Okay, so after you resubstitute the value of u into the equation, only then you can write down 1 and 0 at the bracket. Okay, so now calculate the answer by substituting 1 and 0 into the function. So then we have 1 over 4, 243 over 5 minus 81 over 4 minus 1 over 5 minus 1 over 4. Okay, so then our answer is 1 over 4, 567 over 20 plus 1 over 20. So that gives us 71 over 10. Okay, so our final answer is 71 over 10 by changing back the value of u into 2x plus 1. Okay. Okay, if you are done with this, if you already understand this step, I want to show you there is another one more alternative methods to solve this kind of question. Okay, what I want to show you starts from here. I bring this up over here. So that is 1 over 4 u power 5 over 5 minus u power 4 over 4. Okay, so this is the step before you change the u back into the form of 2x plus 1. Okay, so when we do the integration by substitution, we mentioned that u is equal to 2x plus 1, and we know that integration of 1 and 0 is the value on the x-axis. So this is x equal to 1 and this is x equal to 0. So our function right here has in the term of u. So we can find the value of u right over here for our integration. Okay, so now we take the equation u equal to 2x plus 1. So we substitute value of x into the equation. It becomes u equal to 2 plus 1. So u is equal to 3. So for this part, I'll show you down here. So u equal to 2x plus 1. So we substitute the value of x into the equation. So u is equal to 1. So from here we know that when x is equal to 1, u is equal to 3. So when x is equal to 0, u is equal to 1. So we can form a new integration over here where the integration is between in the region of 3 and 1, where the function is in the term of u. So since our function right over here is in the term of u, we can use this as the integration region of the integration, which is 3 and 1. So 3 and 1 represents the number the term of u. So now we can substitute 3 and 1 directly into u without changing the u back to 2x plus 1. Okay, so now it becomes 1 over 4 3 power 5 over 5 minus 3 power 4 over 4 minus 1 power 5 over 5 minus 1 over 4. Okay, so this is our substitution, and the final answer will be the same as before, that is 71 over 10. So this is our second alternative if you didn't want to change the term of u back into 2x plus 1. Alright, so for this part we will try to find the area of the shaded region. Okay, for example is this graph. So now we want to find the area in the shaded region of between x equal to 2 until x equal to 4. Okay, so for this one we write down the equation of the integration, that is 4 to 1 over x dx. Alright, so when we want to integrate 1 over x, it gives us ln x 4 2 plus c. So then we substitute just like usual. There is ln 4 minus ln 2, and this is equal to ln 4 over 2. Alright, so that is the answer for the area of the shaded region under the graph. So for this part, don't forget to write down unit square because it is an area. Okay, so now we want to find the area under the graph of the region between 1 to 3 on the x-axis. So even though the region falls in the area of negative y, but that doesn't matter, we just integrate the equation like usual. So this will be the equation. So when we integrate, we have x above 3 over 3 minus 4 x square over 2 plus 3x 3 1 plus c. Alright, and then so we substitute 3 cube plus 2 3 square plus 3 and 3 minus 1 over 3 minus 4 over 2 plus 3, and it becomes negative 4 over 3. So it becomes negative 4 over 3 is a negative number because the region falls in the area of negative y, but since this is an area, so that negative is insignificant, so it just can be removed. So then our final answer becomes 4 over 3 unit square. Okay, so for this example number 3, so we need to observe or identify the region that we want to find. So in this graph, we can see that the region that we want to find is bounded to the y-axis, is enclosed to the y-axis. So that's mean it is the area under the graph that going towards the y-axis. Okay, so what we need to do is we look at the equation of the graph function, that is y equal to square root of x. So when we want to find the area under the graph that is enclosed towards y-axis, we need to change our equation, put it in the term of y. So it becomes x equal to y square. So our equation for integration becomes 3, 0, which is the axis y equal to 3 until y equal to 0, and right here we put y square dy because we want to find area between the graph and the y-axis. So the integration gives us y power of 3 over 3 3 0 plus c. So we substitute into the equation, then we have 3 cube over 3, and that will be equal to 9 unit square. So that is the area for the shaded region. Okay, for our example number 4, okay, this is a graph that has cosine graph and a sine graph. So we want to find the area of the shaded region shown in the graph. So what we need to do is that we have to find the area under the sine graph in between pi and pi over 4 sine x dx. Okay, so the region covered for sine x from pi over 4 is this region. So we covered the whole area that I highlighted in yellow. So our problem is that it also covered the area that is not shaded, which is right over here. So to remove that part, so we have to minus the region from pi over 2 until pi over 4 under the graph of cosine x dx. Okay, so then we do our work from this equation of integration. So now let's integrate sine x. So integration of sine x gives us negative cosine x pi over 4 minus sine x pi over 2 and pi over 4 plus c. Alright, so we substitute pi and pi over 4 into the equation. So now we know that pi is equal to 180 degree. So negative cosine 180 degree minus negative cosine, and pi over 4 is 45 degree, minus with, so sine pi over 2 is 90 degree, minus with sine pi over 4 is sine 45 degree. So then you can use your calculator to find the value, or you can use the triangle that you learn during the trigonometric function, then to find the value of cosine angle 45 and sine angle 45. So for this one, it gives us 1 plus 1 over square root of 2. So square root of 2 is equal to the negative cosine 45. So minus 1 minus 1 over square root of 2. So square root of 2 is equal to sine 45. So our answer will be 2 over square root of 2 and just equal to square root of 2 unit square. Alright, so this part we will look at on how to find the volume of solid generated. Okay, this is about volume of solid. Okay, so we have a shaded region on the graph of y equal to exponent power of x. So how do we find the volume of solid generated when the area rotated 360 degree on the x-axis? So that arrows indicate that it rotates on the x-axis. Okay, so in order to find the volume, what we need to do is we take the integration of our function just like usual. That is exponent x dx. So exponent x is the equation of the function. So in order to find the volume, we have to add a few components into our integration. So for example, is we need to add pi in front of the integration, and our function, that is exponent x, must be squared. So it becomes, so this still 4 and 0 because the region is from x equal to 4 until x is equal to 0. So then we just integrate this like usual. So exponent become exponent to x dx, so equal to pi exponent to x over 2 4 0 plus c. Alright, so just like usual, we substitute 4 into the equation. So it becomes pi exponent to the power of 8 over 2 minus exponent power of 0 over 2. So then we have pi over 2 exponent to the power of 8 minus 1. So this will be our final answer for the volume generated by the shaded region when it revolves 360 degree on the x-axis. But one more thing before we finish our answer, don't forget to write down the unit. So since that it is a volume, so then the unit must be the power of 3. Okay, so our second example for calculation of volume of solid generated. Okay, but this time the area the solid generated revolve through the y-axis, so it rotates on the y-axis. So then we need to find the equation of the integration. So this is our volume. Okay, so since there are two parts of the region, one that is bounded to the y-axis under the graph of x plus y equal to 2, and down here is the region bounded between the graph of y equal to square root of x, and both are bounded to the y-axis. So we need to change the term of the equation into the term of y. So our equation becomes x equal to 2 minus y, and another one is x is equal to y squared. So our volume for x equal to 2 minus y is between 2 and 1, 2 minus y square, because we want to find the volume generated and place a pi in front of the integration. So that is for part number 1. For part number 2, we need to plus another pi because it's another volume. For 1, 0 for the equation of y square, and another bracket of square dy. Oh sorry, right down here I mentioned y. I should mention y, not x. Okay, so this is our equation to be integrated to find the volume generated by this graph. So we have here is 2, 1, 4 minus 4y plus y square dy. So that is where we expand the bracket, plus pi 1, 0 y power of 4 dy. So now we integrate the equation, become 4y minus 4y square over 2 plus y power of 3 over 3, 2, 1 plus pi y power of 5 over 5, 1, 0. Alright, so now we substitute our value into the equations. So it becomes 8 minus 8 plus 8 over 3. This is part where we substitute value of 2. So part for substitution of value of 1 become 4 minus 2 plus 1 over 3. So for another part is just pi over 5. So then our final answer is pi over 3 plus pi over 5. Then it becomes 8 pi over 15. So that is our answer for the volume generated, and don't forget to write down unit to the power of 3. So that's all for this chapter of integration. That ends until the volume generated. And if you have any question, if you want to ask regarding this video or regarding the examples or anything, you can just WhatsApp me privately or personally anytime, or not anytime, but during office hour. Okay. Okay, maybe that's all from me for this chapter. Thank you and Assalamualaikum.